Today's chapter is sphere. So before knowing sphere, we need to know a little bit about three-dimension geometry. Like two-dimension coordinate system, there are two coordinates, x and y, and there are two axes also, x-axis and y-axis. But in three-dimension coordinate system, there is total three coordinates, x, y, z. We can draw it like this. So here, before knowing sphere, we need to know that what is a plane. So the general equation of a plane in three-dimension coordinate denoted by ax plus by plus cz plus d equals to 0. This type of equation is known as plane, where a, b, c, d are the unknown constants. Now the sphere is the surface which is the locus of a point. This fixed point which is called the center of the sphere, and the constant distance is called the radius. Just like the circle in two dimension, this becomes sphere in three dimension. So in general equation of a sphere is x minus x1 its whole square plus y minus y1 its whole square plus z minus z1 its whole square equals to d square or r square, whatever. So this is the standard equation. So here center is the x1, y1, z1, this point, and the radius is r. There is also another form of a sphere which looks like this: x square plus y square plus z square plus 2gx plus 2fy plus 2hz plus c equals to 0. This is also represents a equation of a sphere. Check here the same coefficient for x square, y square and z square, and there is no xy or yz such type of terms. So this represents an equation of a sphere. So in that case the center will be minus g minus f minus h, and the radius will be root over g square plus f square plus h square minus c. Okay. Now let's solve one example. Find the center and the radius of the sphere 3x square plus 3y square plus 3z square plus 2x minus 4y minus 2z minus 1 equals to 0. This is the equation of a sphere. We need to find out its center and radius. So what we are doing, we need to make it in this standard form. So that's why we are taking common 3. So it will become equals to 0. So here g will be, if you compare it with that standard form of sphere's equation, here g will be 1/3, this one, then f will be minus 2/3, and then h will be minus 1/3, and c will be minus 1/3. So the center is minus g minus f minus h. So the center will be minus 1/3 minus minus plus 2/3 minus minus plus 1/3. This is the center, and the radius is root over g square, that is 1 by 9, plus f square, that is plus 4 by 9, then h square, that is 1 by 9, minus c. So minus minus plus 1/3. So it will become 6 by 9. It will give you 2 by 3, that is 1. So radius is 1 unit and the center is denoted by this point. Okay. So this is how we find out the center and radius of a sphere. Next topic is equation of a sphere when the diameter or the extremities of the diameter is given. So here suppose 2 points A, x1, y1, z1 and B, x2, y2, z2 be the extremities of a diameter of a sphere. This point is A and this point is B. Then what will be the equation of the sphere? equation will be x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equals to 0. This will be the equation of the sphere. So let's solve one example. Find the equation of the sphere. Find the equation of the sphere described by joining the point P 2, minus 3, 4 and Q minus 5, 6, minus 7 as diameter. We have to find the equation of the sphere where PQ this becomes a diameter. So P is given, Q is given, just put that values in the above formula, you will get the result. That is, the answer will be x minus 2 into x minus 5, so x plus 5 plus x minus plus, that is x plus 3 into x minus 6, sorry not x, y minus 6, then plus z minus 4 into z minus plus 7 equals to 0. Just open the bracket and simplify it. You will get the required equation for sphere. Okay. Next topic is equation of a circle. Now in 3 dimension there a circle cannot be exist, right? Because circle is a 2-dimensional figure. Circle exists only when, suppose in 3 dimension, when a sphere is cut by a plane. So in that case a circle will form. That means in 3 dimension coordinate system, if we say one sphere's equation together with a plane's equation, then this will represent a circle. Okay, so to represent any circle we will use 2 equations, that is equation of a sphere and equation of a plane. Okay. The next thing is radical plane. Radical plane means when two spheres are cut each other, there it will form a circle, and this plane is called, on which the circle lies, this plane is called a radical plane. And how do we get the equation of that radical plane? Suppose this is the first sphere S and this is the second sphere S dashed, then we get the equation of the radical plane by simply subtracting these two equations, S minus S dashed equals to 0. So this will be the equation of the radical plane. Radical plane means when two spheres cut each other, then they form a circle. Now on the plane is the radical plane on which that circle lies. Okay, so we get the equation of that radical plane just by subtracting these two equations. So let's solve few examples. Find the equation of the sphere. Example 3. Find the equation of the sphere which passes through origin, and touches the sphere x square plus y square plus z square equals to 56 at the point 2, minus 4, 6. It is saying that the equation, find the equation of the sphere which passes through the origin and it touches this given sphere at the point this. That means like this. Another sphere, this point will become 2, minus 4 and 6, and it is passing through origin 0. That means this line will become a diameter for that given sphere, for that sphere whose equation we have to find out. So now we can easily get the extremities of the diameter. Now we can easily get the equation of the sphere, which will become x minus 0 into x minus 2 plus y minus 0 into y plus 4 plus z minus 0 into z minus 6 equals to 0. So this is the required equation of the sphere. Just simplify it and you will get the standard form of a sphere. Next example. Find the center and the radius. Find the center and the radius of the circle x square plus y square plus z square equals to 25 and x plus y plus 2z plus 9 equals to 0. Check, this is the circle. So we take two equations. One equation is of the sphere, another equation is of the plane. So if we draw this, suppose this is the sphere and the plane cutting the sphere over here. So it will form a circle. Now we have to find the center of that circle and the radius of that circle. Now somewhere here is the center of the sphere. Now what will be the center of that sphere? Obviously it is 0, 0, 0. So this point is 0, 0, 0. And if you join this length, this will become the radius of that sphere. And what will be the radius? It is 5 square. So radius will be 5. Now we need to find out the radius of that circle. That means this point. Now we know this is 5. Somehow we can find out this length by Pythagoras theorem. We can easily get that value, right? So this is actually the distance of the plane from the point 0, 0. So this length, if we name it A, B, C. So BC is actually the perpendicular distance of 0, 0, 0 from the given plane. So find out the distance. Distance finding is just put the value over here. That is 0 plus 2 into 0 plus 2 into 0 plus 9 by root over sum of the squares of the coefficient. Here the coefficients are 1, 2, 2. So it will be root over 1 square plus 2 square plus 2 square. By after calculation we are getting the value will be 3. So the required length is 3. Now we got that value and this value also. So just apply Pythagoras theorem to get AB. By Pythagoras theorem we have AB square plus BC square equals AC square. So AB square will be AC square minus that BC square. That means it will become, the answer will be 16. AB square will become 16 after calculation. So we are getting AB equals to 4. That means 4 is the radius of that circle. Okay. So this is how we find out circle center and the radius of that given circle. Such type of examples are very important. Next, there is another thing which is pretty much common in exams question, which is called great circle. Great circle means when the sphere, the center of the sphere lies on the radical plane. When the center of the sphere lies on the radical plane. That means suppose this is cutting, this is the center and this is the radical plane. When this happens, the center of the sphere lies on that radical plane. When it is cutting by another sphere or by another plane, if happens, this condition satisfies, this is called great circle. So let's solve one example using great circle. Find the equation of the sphere for which the circle x square plus y square plus z square plus 7y minus 2z plus 2 equals to 0, comma 2x plus 3y plus 4z equals to 8 is a great circle. Find the equation of the sphere for which the circle is a great circle. So now to have to find out the equation of the sphere. So how will we take the equation of the sphere? We will choose it this plus some constant lambda into this thing. So answer, let the sphere is the first equation x square plus y square plus z square plus 7y minus 2z plus 2 plus lambda into 2x plus 3y plus 4z minus 8, this equals to 0. Now opening the bracket, it will become x square plus y square plus z square plus 2 lambda x plus 3 lambda plus 7 into y, then 4 lambda minus 2 into z minus 8 lambda plus 2 equals to 0. Okay, now what will be the center of that sphere? It will become minus lambda, this is our g, 2gx, so the g will be lambda, that is center will be minus g, so minus g, that is minus lambda, then minus half of 3 lambda plus 7, then this thing minus half of this quantity, so if you take half it will got cancelled, so we are getting minus of 2 lambda minus 1. So this becomes the center. Now it should become a great circle. Now what is the condition for great circle? The center of the sphere should lie on that radical plane. That means on this plane. So if you instead of x, y, z, if you put the value of the center's coordinate, it should satisfy. So if you put 2x, that is 2 into minus lambda plus 3 into y, that is minus half into 3 lambda plus 7, then plus 4z plus 4 into minus of 2 lambda minus 1 equals to 8. Now this is the linear equation of lambda. You can easily solve it just by opening the bracket and simple calculation. So we are getting the value of lambda equals to minus 1. Now put that value minus 1 in that equation. Put lambda equals to minus 1. You will get the equation of the sphere, which is actually asked in the question. Okay, so this great circles example is very important for exam. Just have to remind one thing, that the center of the sphere should lie on the radical plane. That's it. Next we have another example. Next example. Find the greatest and least distance. Find the greatest and least distance from the point 2, minus 1, 1 to the sphere x square plus y square plus z square minus 8x plus 4y minus 6z plus 4 equals to 0. We have to find the greatest and the least distance of that point from the sphere. So from this sphere, at first find out its radius and its center. So center will be, if you compare it with it, g will take the value minus 4. So minus g will become 4. Then f will take the value plus 2. So minus f will be minus 2. Then similarly minus h will be 3. So this is the center of the sphere. Okay, and radius will be root over 4 square plus minus 2 square plus 3 square minus c, that is minus 4. So after calculation we are getting this value as 5. So this is the radius of the sphere. So check, this is the center, and the radius, you name it as r equals to 5. Now let's check at first that point P lies outside of the sphere or inside of the sphere. So somewhere there is P and this is the center. Let's check the value of CP. CP. We know how to find the distance between 2 points. C is 4 minus 2 3 and P is given in the question. P was 2 minus 1 1. So simply apply the rule, root over 4 minus 2 its whole square plus minus 2 minus minus plus 1 its whole square plus 3 minus 1 its whole square. After calculation we are getting this value is 3. So CP is 3. That means this is less than R. So P will be somewhere here. That means this is our CP. Okay. So we have to find out the greatest and the least distance of the point P from the circle. So the greatest from the sphere. So the minimum distance will be this length and the maximum distance will be this length. That is, the minimum will be R minus CP and the maximum will be R plus CP. Check, this total length is R. This is CP. If you subtract R minus CP, you will get R this length. And if you add this CP plus this length also R, you will get the maximum distance. Okay. Now we know both the values, you can easily get this. This one will be, maximum will be 5 plus 3, that is 8. And the next one will be 5 minus 3, which is 2 units. Okay. So minimum distance is 2 units and maximum distance is 8 units. So this is how we find out the greatest and the minimum distance of a point from a sphere.